Welcome back, everyone. As you may remember from my previous video, I detailed this particular water pumping system for like a desert condition with a low flow spring, and how to actually make the system run and be as efficient as possible and supply a house that's sitting either in the valley or on the hillside. In the primary example, it's on the hillside, but it could be in a valley too if it needs to. But anyways, this is where we left off at the last time. And I wanted to pick up on this because I did promise that I would cover how I take this system and make use of these water tanks down here that are storing all the wastewater from the ram pump, especially if you get into a situation where this is barely running or not running at all. These are full and this is empty. So how do you deal with this? Well, since the only stipulations, like I said last time, is self-imposed, here's the scenario. You're in a house out in the desert. You don't have regular mains power. You do have a solar array, so you have a power source because you're obviously going to want to have lights and your refrigerator and all that kind of stuff in your house. But like I say, if the rain isn't coming and it's really dry and your spring dries up or it's not producing enough water for your needs, how do you take this and actually make use of this water down here that you've been collecting this whole time? Okay. Oops. Come on, you. There it goes. You do it with this. These two red blocks here are water pumps. The kind that I used in my thought problem was the RV style 12-volt SureFlows, which would work perfect with a solar power system because it's, if the system is 12 volts, they have SureFlows for that. They also have SureFlows for 24 volts. And if your system is 24 volts and you can't get a hold of the 24 volt SureFlow, you can just use a step down transformer to go from 12 or 24 to 12 and still get what you need. But anyways, basically what happens here is, in this design, you have the pump down here, and this is assuming this isn't running. This turns on. And that's still the part of the problem I haven't figured out yet, is how to turn that on automatically. I've got part of it figured out. I'll post it when I do get it figured out completely. But anyways, this draws from the tank and it pumps up into the headline, or the hose that goes up to the filter block. Because again, the water coming out of here is gray water. It's not filtered. It is not potable. So if you run it through here, you need to filter it first. So you run it up, match it into this hose, or tee it into the hose, either one. Goes through the filters, comes up the hill. Now, you see this one here. This one is right next to the house. But if this one's in the line, how is the ram pump able to pump past it? Because these RV water pumps act like a check valve when they're turned off. Doesn't matter how much pressure you put on the backside, no water's getting through them. Well, actually, they act like a check valve on both sides. But anyways, how do you get that to work if it's in line and you have the ram pump too? Because the reason for this one here is these are only able to produce 55 psi. The ram pump can produce 100, 120 psi easily, because it's got to go up this full distance here. So it can produce the 40 to here and the 40 to here, and enough to do like 60, 80 psi to get up to here. You won't see 60, 80 psi here, but you will down here. But anyways, that aside, what you do is this one pumps up to here. By this point, you've lost all but about 10 psi. So this one can take up to 15 psi on the head end, or the inflow side, and then it pumps it out at 55 psi to this. Now I have a system that I'm working on that will both monitor the tank volume and have the ability to turn these on and off as needed, based on the amount of water in here and the amount of water in here. Since you don't want to run a SureFlow, you don't want to run them dry for very long. Basically, this would also have a monitor down here so that when the water in these tanks hits bottom, this turns off. Of course, this turns off and this is empty. Yeah, you got some problems, but that's not for this problem. Or this puzzle. Anyways, water comes out of here, goes through here, comes up here, comes up to this. This is basically the junction that you initially run into. Water's coming up from the ram pump, goes up to the storage tank on the hill, and this goes into the house, because at that point it's roughly 40-45 psi. This is how you add in the ram or the water pump. Water's coming up from the other end, and then this thing's in here, and it's just and it's pumping water up the hill. The only problem is, if you have this here and this is all you have, you're just going to run in a loop. It's not going to pump it up the hill. So how do you solve that? You add a check valve. That's how you solve it. It's that simple. Water comes up. If the pump is off, it's not coming through here. Nothing's moving through here if this pump is off. Ram pump comes up here. The pressure builds up and it eventually overcomes the back pressure from the tank. Valve flips open. Water goes up the hill. If the ram pump isn't running, you got the down pressure from the hill. It's got that valve locked. Pump turns on. It takes the water in from this side. Let's say the other one's running first. This is going to push this open briefly, but then as soon as this kicks on, the water pressure back here is going to just crater. It's just going to fall right off. And the water then comes through here, up here, and starts building pressure here, which takes this check valve and slams it shut. Because any backflow that comes through here is going to slam that thing shut anyways. And if you do it right and you mount your check valve so that the check gate is hanging down, gravity by itself will close that check valve. If you put it sideways or up, you're going to have back pressure to actually push it back to the closed position. So you should hang it upside. You should hang it with the check gate down, so the gravity just, as soon as there's nothing happening, gravity just goes click and it shuts it. But anyways, that runs up the hill. Sitting there doing its thing. You've still got pressure in the house. Your tank, your tank up here is filling. It's running up the hill doing the thing. This gets up here, and of course, like I said, I got an automatic valve. They're automatically shut off for this. And I'll also have in my design, I'll have a manual bypass that I can manually turn this on, which then ignores the control switch up here and the control switch down here, and just turns these on live, and off you go. But once I figure out the design, I've got it mostly figured out. But yeah, there's going to be basically a check in here that's going to say, okay, this is empty, this is full, and here's the various positions in between. This is empty, this is full, here's the various positions in between. And it'll run a switchboard in the house that tells you how full each of your tanks are. And it will automatically turn these on if you have this enabled, which you can actually have it turned off, which will be another part of this where I can turn it off completely. And it does not turn on automatically, even if your system runs out of water. Or your upper tank runs out of water. Because if this is out of water, ain't nothing running. Because the safety system is going to be set up so that this does not turn on if these are empty. But if these have water in them still, and this is empty, yeah, it'll turn on. And then you can manually turn this on as well. But anyways, that's the system that I came up with, which was the secondary system that's, again, outside the original puzzle. But it was another puzzle that I created for myself, and it solves the whole water flow problem. Now, that being said, oops, sorry, try that again. There we go. This system is very, very simple. Even if you don't have this little cutoff, let's just say this part down here doesn't exist, and it just goes like this. You could build this into any system you want to. The SureFlows have a 15 psi maximum on the inside, or on the inflow, so you have to take that into consideration when installing this. But you can install this on literally anything where normal water flow pushes open the valve, goes by, and it just bypasses the pump. The pump just sits there and it just kind of twiddles its thumb and does nothing. As soon as the water flow stops and the pump is turned on, off it goes, and up the hill or wherever it's supposed to go goes the water. So you still got water flow even though you don't have any downstream pressure, for example. Now this thing can pull 6 feet of fall. In other words, it could be 6 feet above the water source maximum, and it can still pull the water up and into the pump. Anything above that, and it just sits there and spins. Even if it's primed. But yeah, if you've got at least neutral pressure up to, let's see, 6 feet would be about couple psi on the negative. Let me take a quick bit of math here. Yeah, 2.4 to the 2.4 psi to the negative. So yeah, it could still run and do its thing, but again, oops, doggone it. This, is going to have your base pump, which is going to be feeding this one, which is going to be feeding that. So, and by the time it gets up into the tank, you're talking, if it's 100 feet and it's 40 psi at 100 feet, you're probably going to only have 15 psi by the time it gets to the tank, which is fine. You're just filling the tank. You're not running a faucet or taking a shower. So, that'll be enough to fill the tank. It might suck down your solar batteries, but it will fill the tank for you, and you'll at least have water. So, anyways, that was the new puzzle I wanted to show you. And if, again, like always, if you have any questions or comments, thoughts, maybe a better way to do it, a different way to do it, so on and so forth, just let me know. I'm always up for new ideas, new ways of doing things, insights, thoughts, stuff like that. Anyways, see you next time, because I'll have more puzzles coming up in the near future as I get a chance to draw them up. And yes, I still admit that my drawing sucks, but hey. Anyways, see you guys.